Okay, lesson 12, page 218, problem number 19. So this is an explosion type problem, yes? And basically, if we consider the two of them as our system, there isn't anything coming from outside that dotted yellow line, so we know that the total momentum inside the dotted line is the same in both cases. So basically, over here, there's a spring between the two ice skaters, and they're holding on to each other. So basically, with their hands, held together here, and their hands held together there, basically they don't let the spring go. Okay, but then once they let go, this person ends up going this way. This one ends up going that way. The spring probably just drops to the ground. It's insignificant compared to their masses, and basically. One of them is called Al, and one of them is called Joe. Is that correct?
Right.
Okay, so Al and Joe. Now, basically over here, if we want to know what their momentum is, it's going to be the mass of one of them plus the mass of the other guy, yes? Added up times their combined velocity, that'll give us the total momentum to begin with. But now they separate, so their momentum is going to be the mass of the one times the velocity of the one plus the mass of the other one times the velocity of the other one, yes? Now, are they still to begin with? Yeah, it seems like they start from rest, yes? So since they're starting from a rest, from being still, what's going to be the initial momentum over here?
0.
Right, because this basically here is 0 meters per second. So this whole term goes, so we have 0 equals, and then we don't know the mass of Al, do we? Okay? I think that's what they're asking for, correct? The mass of Al? But we do know that Al goes back 0.90 meters per second. But since she's going to the left, I have to make that negative. So it's going to be negative . And do we know the mass of Joe? Oh, they gave us their combined mass. So if we know their combined mass is 168, 168 kilograms is combined mass. So basically, what can I put in for an expression for Joe's mass?
168 minus mass.
Yeah, so that's going to be 168 kilograms minus Al's mass. So this is the mass of Al. This over here is the mass of Al. And parentheses. And how fast does he go off?
1.2.
And that's to the right, so that's going to be positive 1.2 meters per second. So, although it's not the prettiest looking thing, it is one equation with one unknown. So basically what you're going to have to do is distribute this 1.2 like that. Yes? And then add like terms, and then solve for Al's mass. You good to go from there?